Have you ever wondered how transistors can be tested to know if it is working or not? Watch till the end and find the answer. Components needed: 3.7 volt battery, lead, 1 kilo-ohm resistor, limits lead current, 10 kilo-ohms resistor, gate pull-down resistor, push button, N-channel MOSFET, IRFZ44N in the video. Connections: the source of the MOSFET transistor is connected to battery negative minus symbol, while the drain terminal of the MOSFET is connected to lead cathode. Lead anode is connected to battery positive plus symbol through the 1 kilo-ohm resistor, and gate of the MOSFET transistor is connected to push button. 10 kilo-ohms resistor between gate and source. How it works: 1. When the button is not pressed, the 10 kilo-ohms resistor pulls the gate voltage down to the source voltage. Therefore, V_GS equals 0V. The MOSFET remains off. No current flows through the lead. The lead stays off. 2. When the button is pressed, battery positive is applied to the MOSFET gate. The gate becomes positive relative to the source. The MOSFET turns on. A conductive path forms between drain and source. Current now flows. Battery, plus, to 1 kilo-ohm resistor to lead to drain to source and finally to the battery. The lead lights up, indicating that the MOSFET is conducting. Purpose of the 10 kilo-ohms resistor. The 10 kilo-ohms resistor acts as a pull-down resistor. It discharges any stored charge on the gate. It ensures the MOSFET turns off when the button is released. Without it, the MOSFET gate could remain charged and keep the lead on even after releasing the button. How the tester identifies a good MOSFET. Lead turns on when button is pressed and off when released. MOSFET is likely good. Lead never turns on. MOSFET may be open circuit, damaged, or connected incorrectly. Lead stays on all the time. MOSFET may be shorted between drain and source. This tester checks the MOSFET's basic switching action, which is often enough to quickly determine whether an N-channel MOSFET is functional. Thanks for watching and see you soon.